Good morning. I'm Charles Alcock. I'm the director of the Harvard-Smithsonian Center for Astrophysics. And it's my pleasant duty to welcome everyone to the 10th conference in this series on theoretical astrophysics with the timely topic of gravitational wave astrophysics, which I think we're all going to enjoy and profit from. This is sponsored by the Raymond and Beverly Sackler family and by Erwin Shapiro. I think I can do nothing better than to get you all seated, hand the mic over to Avi and get out of the way, because there's plenty to discuss. This is a very exciting time. Thank you all for coming.
Welcome, everyone. I just wanted to mention a few guidelines for the speakers. All the talks will be video recorded. You can see the camera behind you. And therefore, anything you say could be looked at later. So just make sure that you say the right things. We will eventually post all these videos on the conference website. There are press representatives in the audience, so once again, things that you say might appear in the newspapers tomorrow, so just make sure that you are comfortable saying that. We had a conference where Ray Weiss was talking freely, and Vicky Kalogara, who chairs the first session, shouted from the back of the room, "But Ray, you are not supposed to say that." I wanted to mention that next door to the Sheraton Commander, on that side, there is a Greek-looking building that is the Black Hole Initiative. That's a new center that we established about a year and a half ago, and it's funded for at least a year and a half from now. It's the only center in the world that focuses on the study of black holes. Its special feature is that it brings together physicists, astronomers, mathematicians, and philosophers. Philosophers are the most interesting component of this center. And actually, following this conference, which ends at lunchtime on Wednesday, we will have a two-day conference of the Black Hole Initiative, and you are most welcome to stay for that. It's, again, here. And the banquet will be held for both conferences. I just wanted to give you a general impression of the Black Hole Initiative. That's at the inauguration in April 2016, and you can see the principal investigators associated with the grant that we received for that center. It includes Andy Strominger from physics, Peter Gallison from philosophy, S.T. Yao from math, Ramesh Narayan from astronomy, and Shep Dolman from the Event Horizon Telescope, again, astronomy. And Stephen Hawking came especially for the inauguration. It was his first trip over 3 years across the Atlantic. The director of the Institute for Advanced Study at Princeton, Robert Dijkstra, made a special mural for this center, and we have it hanged in the corridor. You're most welcome to visit the Black Hole Initiative. It's just next door. That's the front entrance of that Black Hole Initiative. You can see by now we have a lot of postdocs. Just last year we recruited 6 postdocs, and so it's a very lively place. You're most welcome at lunchtime or at the breaks to visit that center. It's on the second floor of 20 Garden Street, next door. And this is the conference that will follow the one that we are attending now, starting on Wednesday afternoon, focusing on black holes. And speaking about black holes, I just wanted to mention an important aspect of black holes that we tend to neglect, so that you don't think that by detecting gravitational waves, we basically know everything we need to know about black holes. Actually, there is the singularity in the middle that is often not talked about because it's hidden behind an event horizon. But I was reminded of this singularity because at our home in Lexington, about a week ago, we had the basement was flooded. And so I then started thinking about it and realized that, in fact, the reason it's flooded is because usually the water goes down to the sewer line, and the sewer line was clogged, that pipe was clogged. And that led me to realize that, in fact, when we talk about a black hole, you imagine the matter falling into the black hole and going across the event horizon and eventually reaching the singularity, where Einstein's equations break down. And all it means is that we can't really follow the matter through the singularity, because that's where the equations do not apply anymore. And unfortunately, our colleagues from the physics community did not provide us with an alternative set of equations that will tell us what happens to the matter as it approaches the singularity. And that's still an unsolved problem. And it's quite possible that this is the origin of the information paradox that many people struggle with these days, because all the information is going down the drain, this black hole, and it should go to some sewer line, which we don't know what it is. Where is all this matter collecting? If you were to fall into a black hole, where will you go? What happens as you approach the singularity? It's an unsolved problem, very fundamental, and perhaps has some observational implications. Not many people work on it. I just wanted to point it out as a result of the flood that we had in our basement. So I wish you all a very successful conference, and I would like to ask Vicky Kalogara, who chairs the first session, to start the session.